Okay, this video is going to go over electric machine basics. So, the key to operation of electric motors is magnetic coupling. So, let's suppose you have a conductor, essentially a wire, and there is a current running through it. Then there is a magnetic field around that wire. So, if we have this situation, two principles apply. So, the first is that the field exerts a force on the conductor related to characteristics of the current and the field. So in this figure here, we have our wire that's essentially in a circular or rectangular fashion looping around here. That wire has a current that's flowing around it, and then we have a magnetic field that's flowing across this with a flux density of B. So in this situation, we'll have this force that's acting on here that's found with the right-hand rule. So essentially perpendicular to both of these guys here, we have our force that's going to force this side going up and this side going down. So it's perpendicular to both the current and the magnetic field. And so this force actually ends up being equal to B times L, the length of our wire, times I, our current flowing through this. And note that this is actually a really special case of a much more complex phenomenon and principle. But I just want to go over the simple case here. So this force ends up producing a torque, so this wire will start to spin. And then pretty much what's happening here is that we're taking electrical power from that current and that magnetic field, or really the current mainly, and creating rotational power out of this system. So that's the first principle. So the second principle is that we have this magnetic field which induces a voltage in the conductor that opposes the voltage producing the current. And this is specifically for a conductor moving relatively in the field. So we have something called VB is equal to BLV. This lowercase v here, that's a velocity of the wire. And what this VB here is back EMF. That's what it's called in the motor. So if you were to take this wire or physically spin this coil, the back EMF will generate electrical power. So you're taking rotational power and converting it into electrical power in this case. So electric motors and electric generators are both electric machines. So often one can operate as the other. So they both work the same way. Obviously, there are some motors that are meant to focus more on being motors and generators that are more meant to be generators. But in principle, they're essentially two halves of the same coin. And that is the basics for electric machines.